Aloha! Welcome to my channel, Curvature Amateur. I'm your host, Louis Montagne. Today we are in Hawaii. I'm home and we are observing a special place where I first noticed there was curvature in my world. So here we have the island chain of Hawaii. We have the Big Island of Hawai'i. We have Maui, Oahu, Kauai, his little brother Niihau. We have Molokai, Lanai, and Kaʻolave. Excuse me. Also make videos, a couple of videos about the tiny little island here called Molokini. But today we're just going to be looking on at the obvious island of Maui and one tiny little point here on the eastern shore of Hana. And I'm observing from the shores of Hawaii, right at the northern tip of the Big Island. So let's go take a look at what I'm talking about. Right by Hana, there's a little pu'u. A pu'u is a little mound, a little hill, which is mostly a crater remnant. And Hana is a beautiful little town. It's worth visiting if you're on Maui. It's a long drive. They even sell t-shirts selling, "I survived the drive to Hana." So anyway, here's our pu'u. And does it have a pu'u? Pu'ukil? No, that's the island here. So this is the town of Hana. And that little hill here is noticeable from the Big Island. Take a little 3D look. It looks a bit like that from the Big Island. Seen from very high up. And a nice little beach here, and on the other side, if you're adventurous enough and you're not so shy, you can take your clothes off. It's a little clothing optional beach in this little cove. Alright, but that's not what we're observing today. Sorry to say. Okay, so we're going to be observing that from the Big Island. Go back in 2D. And let's just take a measurement while we're here. Between Hana and Hawaii, right on the shoreline. Right on the shoreline. So we got 35 miles right on the shoreline. Okay. Might even have to add another mile. Let's go take a closer look where I was on the Big Island. I was way at the bottom of the hill, close to the airport. Oops. At this point. Yeah, I used to live around here, and we used to walk all the way down here, and that's where I got my shots, along here, here, and here. Okay, so what's the distance again? Quick look at the distance again. Hana. Let's measure the distance, please. A little more to here. Just to, almost 36 miles. All right, let's remember that, 36 miles. Why am I measuring the distance? because we're calculating the Earth curvature that we can see here and we can observe. I'll show you that of my footage I got with my Nikon P900. So let's go see how to calculate the Earth curvature. Earth curvature, there are several websites that can explain to you or calculate the Earth curvature for you, either in miles or in kilometers. And this is my favorite one here because it has a little drawing, and when you apply mathematics, it's very helpful to have a drawing to understand what we're talking about. Not just a bunch of numbers up in the air. So this drawing represents the globe Earth, the sphere, the ball we're supposed to be standing on. It's supposed to be, supposed to be spinning around in space around the sun. The sun's supposed to be spiraling forward in space, but somehow we don't see the stars change from year to year. The background stars. We see the planets move, but not the background stars. So Robert, the expert here, was asked by others at all levels. So in 1 mile, what's the curvature we're supposed to be losing? So we're not supposed to be seeing anything below this height. Okay, they're using 1 mile. Okay, 1 doesn't make much when you're using the Pythagoras triangle. A squared plus b squared equals c squared. When you square 1, it's still 1. Okay, so they started off, Robert or any experts that have concluded that that's what the Earth curvature is. They started with such a number here, 3,963 miles. That's the radius of the sphere Earth. Okay, you see how precise that number is. It doesn't have any dot something behind, any more fractions behind it. It's just a straight solid number, and it's 3,963. It's not 3,900. It's not 4,000 miles. It's not even 3,960 miles. It's 3,963 miles. Excuse my pronunciation. Yes, I am French Canadian. So they used this number, and their answer was 7.98 inches that they lost after 1 mile. Okay, the formula, you might be looking around to try to find it. I'll tell you right now. It's 8 inches per mile squared to calculate the Earth curvature. So you got to measure distance of sight. What was it? 35 miles from Hawaii to Hana. So you got to square that square that distance number and multiply that by 8 inches to the mile, to the foot, sorry. So which is 2/3. Let's pull out the calculator and look at some numbers. Okay, so I'm talking about 2/3. What is 2/3 in calculated numbers? We got 0.6 periodical. All right. So 8 inches in 1 foot should be 2/3. 0.6 periodical, exactly. Now let's check out this number, 7.98 inches in 1 foot. 12 inches, we get 0.665. So it's just a tiny bit less than the value of 2/3. All right. We'll keep our calculator handy and let's go take a look. Take a look at the elevation of that pu'u on Maui. Okay, we got it here. We'll take a closer look. Let's try to see how high this thing is because we're observing it from far away. Let's try to grab the highest peak. What do we have? 341 feet. Okay. Here we get 341 again. 276. 328. 318. So it looks like pretty much the highest point is 341. We saw that's 318. We saw 341 or 351. Okay. And that's the ground level there because it's covered with trees. 367. All right. It's covered with trees, and some of those trees, like the Norfolk pines that we'll notice in my video, can stand up over 100 feet tall. Some old mature ones. That's what you can expect to see. All right, so we got our measurement and we got our elevation. So let's just do the math with our distance here real quick. You can use it over this map here. Just remind us our number. So we got 35 miles. Just stay at 35. Square that number. Multiply it by itself. We get 1225. So now we have to multiply that by 0.665. So we have 814 feet. That we shouldn't be able to see anything below that elevation from 35 miles away. So if I'm with my eyeball along the water's edge here, right at the sea level, I shouldn't be able to see anything lower than 814 feet tall on the other side. Okay? Just do the math again. 35 square multiplied by itself, we get 1225. Multiply that by 0.665 equals 814. We shouldn't be able to see anything below this height, 35 miles away. Okay. Now let's go to the shores of Hana. Very windy. I bought myself an altimeter. Right. It gives us a reading of 6 feet over the sea level. Oh, 3 feet. So it kind of changes because it just sets its altitude with the air pressure. 6 feet now. Okay, you can see that my camera lens is close to the ocean, and I want to get it wet, and I don't want to get any waves splashing at me. So I gotta be careful, stay kind of away. Thanks to those rocks, I'm protected. And across the Alenuihāhā Channel, which is that body of water in front of us, we have the island of Maui. I'm looking at it from the west to the east. West side, bloop, 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 top getting hidden by the clouds. Here's the top, little observatory up there. Let's take a little closer look. Brag about my Nikon P900's powers. Let's go look at what this guy is wearing. No, I'm just kidding. So you can see it's a very good tool to have to look at long distance sights. Now going towards the east side, through the clouds. It's the Kaupo Gap. You can see the clouds in the Haleakala crater through the Kaupo Gap. Well, it's not the purpose of my video here. Let's go down a little further. And you see, that's the eastern end of Maui. And we are not able to see the pu'u we were talking about right now. And the first time I've seen that, ladies and gentlemen, I was always seeing the pu'u from higher up. And when I got to the ocean level, I noticed that, whoa, where did the pu'u go? Look at this treetop here, little reference point. Okay, you can notice this treetop here, close to, looks like the end of the island. So when I saw the curvature for the first time like that, I thought to myself, I thought those flat earthers convinced me already that the earth is flat. But look at this big body, it's bulging, curving water that's hiding the part of Maui I wanted to see. I was kind of disappointed on the spot. But looking into my brain, I was thinking, how would the flat earthers, how would they have lied? All their videos look pretty much convincing to me. But don't throw that theory of flat earth in the garbage, because it's not that far away from reality. The element they don't have, flat earthers, they don't have curvature. They keep claiming that where's the curve? The curve cannot be observed. But we have the curve right here. We just saw it. Right? I'm going to climb up a bit. I'm up at 39 feet. And the good thing about Hawaii, it's got tall islands, especially the Big Island where I live is very tall, so we can see far away if the clouds will allow us. So I went up 39 minus 6, and I went up 34 feet, 35 feet, and it looks like there's another island appearing. Sorry if I shake a little bit. Looks like there's another little island appearing at the eastern point of Maui. So one tree standing in the middle of the water, and then we have separation, and it looks like a little island sticking out. And you can see our tree on the left side, if I can get to there. Birds are having a good time fishing. Skip a little bit. See our treetop here? You saw in the first shot. It's already higher up. And looks like another little piece of island appearing. Alright, next shot. Now I'm up to 42 feet of elevation. And we're still looking towards Maui on the eastern tip. And we can see that the island we were just looking at got a little bit bigger, and the distance between the island of Maui and that little surprise island here has gotten a little shorter. So yes, I was kind of disappointed not to see that the world was flat, but there's no way I was going back to the globe model after understanding everything that I did see on YouTube. 62 feet of elevation here, keep climbing up. At 62 feet, remember, 62 feet. And what do we see? So that we can recognize our treetop here. That looked like an island earlier, but it's now joining the rest of Maui. And we have, ding, a little top here of another little island. Okay? And I believe that's the top of our pu'u. Our pu'u, which stands 360 feet tall, plus some trees. We can put it up at 400 and some feet that we're seeing here, over the water level. And remember our calculator, what we had? We weren't we shouldn't be able to see anything below 814 feet. But at 60 feet where I am, I can see 360 feet plus 100 feet. So there's still some numbers missing that would make us up on the globe scale here. Next video. So I am up at 82 feet of elevation. 75, 78, whatever my altimeter feels like. 82, 78. Okay, we're about 80 feet or so. Let's see what we got. Zooming in. Sorry if the level of the tripod's not perfect. So we can see our treetop up there. And that first island that was appearing to us. And far away we can see that pu'u showing a little bit more of its top. It looks like we can clearly see the ground level here beneath the height of the trees. I mean, not clearly, but good enough to estimate that we're at the top of the pu'u here. And I'm just at 80 feet. 80 plus 360 is what? 420? No. 440? I'm still very far away from 814. Alright, next shot. I'm up at 104 feet. Keep climbing. Don't need to hear that. So, 20-some feet higher up, we saw our tree up there, our little first island, and then we see some Norfolk pines sticking way up, measuring over 100 feet tall. They look like they're standing in water. And we see more of our pu'u on the eastern tip of Maui. You even see some lone trees standing in the water. Alright, next shot. Now I'm getting more into cow territory. Never know, might face a cow or a pig, wild boar. So now we see a little bit more again. And we went up, did we see the elevation? I've gone up at least 20 more feet of elevation. You see more of that little pu'u. Alright, see more Norfolk pines standing in the water. Alright, next shot. Now you can even see it. Oh, that's not a good video. Sorry. Now we're 147 feet. And what do we see? I get a view between the trees. That's still Maui. And we're looking towards our pu'u by Hana. Okay, pretty much the same as we saw before. You can see a bit more of the Norfolk pines. You can see more of the grounds beneath them. And the distance between the Norfolk pines and the island keeps shrinking a little bit. Okay, next shot. $173 feet. What can we see over the Alenuihāhā Channel? We see a bit more Norfolk pine sticking out. There's a new one here, a loner. You didn't see this one before. You can almost see some other things sticking out over the curved water, the horizon here. Must be a banyan tree, the round one, and Norfolk pines, the tall ones. And remember our tree up here keeps getting higher up on the hill as we climb higher up with the camera. It's a little bit harder to find some view when I get close to the trees. It's still good enough to observe. We're up at 186 feet. And we can see more treetops, more Norfolk pines. And it looks like the distance between that little pu'u, which looks like an island, and the rest of Maui, the distance keeps getting a little bit narrower. Okay. Next shot. $282, $278. I went up a little too high and I can't see much. I didn't even put up my tripod because I had to keep the camera at the upper reach of my arms. So here we see the land totally stretched out. It's not an island anymore. Oh, sorry. Like I said, I didn't set up my tripod at that one shot. I had to hold the camera up over the tall grass. But yeah, you can see the whole thing. It's not an island anymore. But I'll show you better in some other shots. I wasn't as high up. Here I was at 278. How was I? 282, 278, yeah. All right, next one. I'm gonna be a little bit lower on the field. 239. And I took time to set up my tripod for your visual comfort. And you can see I back down from 278 to 239. I went back down like 40 feet or so. And we can barely see the shoreline. You cannot see the shoreline. We only see the treetops on Maui. But we can see that it links that pu'u to the rest of Maui. Remember our treetop, first treetop? You'll see it better next one. From 249, 249 feet of elevation that I'm standing. And looking at Maui again, at the easternmost point. And we can see land stretching all the way across. So those trees, they don't look like they're standing in water anymore. They have their grounds. See a Norfolk pine standing high over all the other trees. These must easily be 120 feet tall. You can see the whole, not the whole height of the pu'u, but we can see most of it. looks like the sun is setting on Maui. There's our tree up there, first tree we were looking at. That's the first island we saw. And now our pu'u is almost complete. So that's it for what I want to show you, isn't it? What about this one? This one, we can see that's on another day. The other one. Here it is. That is a job site I was working on. I cut all these bamboos and got them chipped for this guy. And I pulled out my camera in front of him. See some bees in front. And that's higher up on the mountain, and I'm standing at around 1,500 feet of elevation, maybe a little bit less. And we can see clearly, not clearly now, we can see the waves splashing on the shoreline. We can see some treetops here on the right side, which we couldn't see earlier. And you can see that the level of the ground there is higher up. You can even take a quick look at the elevation map. About the grounds. Those grounds here. What's the elevation of those grounds? 92 feet, 135 feet, 108 feet, 115 feet, 62. So on average we have about 100 feet of elevation in this area. And back to my video here. Have it. Come on. Wait. Go back to it. There we go. You see that's about 100 feet of elevation. And that's where we were seeing from what I was 240 feet or so. At 278 feet I could pretty much see the whole thing. But anyway, is that far enough from this number here that would put us on a globe? But we see broader. Okay, our globe is not as narrow. It's the curve of the ball is not as steep as these guys claim it is. So we have something different than a ball. If I see a curve on my knee, does that mean my leg is round? No. Even if we see the sun and the moon look like a ball, doesn't mean like our Earth is the same shape, does it? No guarantee about that. Anyway, like I said, this was the place where I first saw the curvature. And it's not my first video, but it's the place where I first saw it. So please, thank you. Please come and watch some more of my videos. Curvature amateur. I got more footage to show you. Mostly in Hawaii, at home. Thank you for watching. Aloha.